when it comes to NAD, it almost sounds, oh, it cures everything. It's a miracle molecule, you'll hear people say. But it is actually true that it does have such a vast array of effects. A lot of people are taking supplements to boost their NAD levels. Nicotinamide Riboside or NR, nicotinamide mononucleotide, NMN. Some of it does get incorporated into NAD and boost NAD levels, but you can give as much precursor as you want. But if you don't have that enzyme that's actually making and recycling the precursor, then basically you're not really going to get a sustained boost in NAD. And a lot of the data shows it may actually make some of the issues of NAD decline worse.
What? Dr. Nichola Conlon, welcome to the podcast.
Hi, thank you so much for having me, Inka.
Very excited about this interview. So you're a molecular biologist who is specialized in the study of cellular aging. You're also the founder and the lead scientist at Nuchino Laboratories. And you're also all around the internet in podcasts and articles, helping people to reverse aging and improve their health span. So it's going to be a super interesting episode today. In today's episode, I'd like to discuss reversing aging, how to preserve youthfulness and vitality and health as long as possible. I'd like to know about the current state of research in longevity, and especially I would like to know more about the molecule NAD and NAD supplements, which have become a hot topic in recent years in longevity research and in health space in general.
Yes, very interesting area. It's certainly become a buzzword in the last couple of years.
Yeah, so why aging and anti-aging has so much attention right now in health? Is there just more research efforts or some significant breakthroughs in this field with the past few years?
I think the field of aging has really had a real boost over the last decade. When I first got into this space, which was probably around 2013, 2014, it was just starting where there were being experiments done that were demonstrating that we could actually turn back the clock, so actually reverse aging. And up until this point, even many scientists within the field of longevity and aging research weren't convinced that it was actually possible. But since, that time, probably the last 10 years, there have been huge advancements that have actually unequivocally demonstrated that actually you can turn back cellular aging. You can take an old cell and you can literally make it look and act like it is young again. And, the evidence has become so strong now that you will not find a single person within the scientific community that will say this isn't possible anymore, because the evidence is so strong. And I think that's what's been a huge breakthrough. And I think that's why we're hearing a lot more about it, because it is possible. The evidence is strong. It can't be ignored. And at the end of the day, aging and some of the things that come with aging are quite unpleasant. It's a real loss of our health and independence for many people. So if there's anything that we can do to actually slow that down and extend our health span, that's a positive thing. So I think that's why we're starting to hear a lot more about it. There's certainly a lot more investment being put into the space. So it's a really exciting time to be involved in longevity research, I would say.
Yeah, definitely. Wow, that sounds so mind-boggling to me that you can actually make cells act and feel younger. What does that mean to a normal human being as a whole? Like, if you are able to reverse your aging, does it mean that you start to look younger, feel younger? What does it mean in practical sense?
Well, I think what many people don't realize is actually aging is our biggest risk factor for all the major chronic diseases that we are suffering from. So getting older is actually worse for your health than a lot of other things, that we're told are bad for our health. And for a long time, people thought, well, it's aging, it's natural, it's something we can't do anything about. Therefore, we just have to accept that in the future, there's going to be a point in our lives where we're not going to be in good health. We're probably, going to have declining cognitive function. Our bodies aren't going to work as well. And maybe we'll end up in a care home. And now I think what this shows us is that actually there is an alternative, and scientists are really working on how do we reduce that period at the end of our lives when we're not in such good health. So this is all about, the difference between lifespan and health span. So we're very fortunate now that we actually have long lifespans, even up to a couple of 100 years ago. We were quite lucky if we made it into our 40s, 50s, because, due to lack of sanitation and medicines and things like that, we would probably die during childbirth or an infectious disease or something like that. But now we're living much longer due to all of these advancements. But unfortunately, our health span, so the proportion of our lifespan that we're actually living in good health, is not matching this long lifespan. So what it means for the average person is that if we can find ways to slow cellular aging, to reduce our risk of these chronic diseases that are associated with aging, then maybe we could actually be living our long lives, but in good health right till the end.
Okay, so how I understand this is we have a health span, and the aging is more about the what comes after the health span when we start to decline in health.
Yeah, absolutely that. So we know that, for example, in the UK, the average lifespan for a woman at the minute is 83 years old, but her average health span is only expected to be 63 years.
Wow.
So that's a whole 20 years where that person will be experiencing ill health. And when we say a loss of health span, we usually mean at least two diseases coexisting.
Wow, okay. Is aging something that we should all pay attention to all the time, or is it more like you can only start reversing aging when you're older?
So what we know is that our cells are constantly subject to a barrage of insult, and that's from outside things like UV radiation, poor diet, toxins, all sorts of things like that, but also our internal metabolism. So just by breathing and being alive, our mitochondria, which are the energy powerhouses of our cells, are actually releasing damaging free radicals, which are constantly damaging our cells. Now, what we know is that our cells are very, very good at repairing this damage and keeping on top of it. And it seems like when we're young, they manage to do this. So our cells have various repair processes, for example, DNA repair enzymes, and they're constantly going around making sure that any damage is fixed before it ever becomes an issue. But after the age of about mid-20s, these processes actually start to decline, and they start to not be able to keep on top of the level of damage that is sort of accumulating within our cells. So I think one thing that's important is, although we tend to talk about it as anti-aging or, use that term, it's actually more about protecting cellular health, because everything that we experience as aging ultimately starts in our cells. So from any age, the more that you look after your cellular health, the longer that your cells will be able to keep on top of damage, and ultimately be able to slow the aging process.
Okay, great. Let's discuss NAD. So you're expert in all related to NAD. What is NAD and what does it do in the human body, and why people talk about it so much at the moment?
Yeah, so NAD has been a really exciting breakthrough in the field of aging research. And basically, it's actually something that's been known for a very long time, because it's a natural molecule that's found in every single cell in our body. And it's known to be incredibly important for coordinating over 500 different reactions. So, really critically important. But the two that it's most famous for are firstly energy production. So our mitochondria in our cells, which literally, take the food that we eat and convert them into the energy that our bodies need. NAD is a critical part of the process that does this. It's called the Krebs cycle. And without NAD, we literally couldn't produce energy. So this is why I always say if we didn't have NAD, we'd literally be dead in 30 seconds because our bodies wouldn't be able to produce energy. The other thing that's really important for is actually coordinating a lot of cellular maintenance and repair processes. So NAD is known to switch on a lot of pathways that are associated with keeping the cell in good health. And there's two most famous ones, I guess, are the DNA repair enzymes. So these enzymes go around the cell, repairing any damage that we get, which occurs constantly in our cells. And NAD is important to power these enzymes. Without NAD, they do not function. The other pathway that's incredibly important is the sirtuin pathways. So these are what sometimes are referred to within our space as the longevity proteins. And what these do is they basically sit at the top of many different pathways that promote good cellular health. So when the sirtuins are switched on, they will regulate gene function to make sure inflammation is reduced. Autophagy is switched on for good recycling in the cells. They'll make sure that a lot of our metabolic processes and pathways are functioning well, that there's a lot of repair processes switched on. And again, the sirtuins cannot function at all without NAD. NAD is literally the fuel that they need to function. So the collaboration between NAD and the sirtuins is what powers many of the beneficial downstream effects of NAD. So as a general rule, I always say to people, just remember, high NAD means lots of energy production and lots of repair, and low NAD means low energy production and low repair. And the reason why it's become such a big area of research within the aging space is because NAD levels are actually found to decline in our cells as we age. And obviously this is a problem because low NAD means less energy, it means less repair. We see an accumulation of damage in the cells, and this ultimately leads to a lot of the sort of signs and symptoms that we associate with aging and getting older. So now there are hundreds, if not thousands, of studies that have demonstrated that actually restoring cellular NAD levels can literally, switch back on youthful repair processes, switch back on youthful mitochondrial function and energy production, switch the sirtuins back on and all the beneficial things that they're associated with, and overall really improve cellular health.
Wow, okay. So I'm definitely convinced that NAD is something that everyone should know about if they want to reverse aging and maintain youthfulness. I definitely want to know more about how we get NAD, how we can maintain its levels. But before that, I want to ask you that people are concerned a little bit about different things. Someone's concerned about getting an Alzheimer's. Another one is concerned about skin aging. A third one is concerned about sarcopenia. Is the mechanism the same? Let's say, would NAD be important in all of these aging processes?
So we know that NAD is actually important in all of those processes. So in skin aging, in sarcopenia, and in Alzheimer's, that has been proven. We know it declines in the skin. We know it declines in muscle. We know it declines in brain, and that's all been proven in humans. So I think when it comes to NAD, it almost sounds, it cures everything, and it's a fix for everything. It's a miracle molecule. You'll hear people say. But it is actually true that it does have such a vast array of effects. And again, it makes sense when you think about the fact that it is in every single cell, and it's absolutely critical to, critical cellular functions like energy production and repair. So it does, impact every cell in the body when it declines, and it also improves every cell in the body when it actually increases as well.
How much does it decline with age, and when does it start declining?
So it depends on your lifestyle as well. So lifestyle can have a major impact on the levels of NAD. So poor diet, obesity, alcohol can all reduce your NAD levels. But the sort of average statistic is that your levels will halve every 20 years, and that's from birth. So even by the time you're 20, your levels have halved, then the levels you had at 20, half again by the time you're 40. And this is why when you look at a lot of the graphs that describe NAD decline, it's really quite a steep drop off. It's an exponential decline because of this, which is pretty scary, again, when you consider and learn how important it is to realize that by the time we're, you know, in our 50s, 60s, our levels of NAD that we have are very small compared to what we had when we were younger.
Wow. Okay. What would be the worst habits for declining NAD? And maybe what would be the best ones as well?
Well, the worst would be not exercising and overeating. Basically, the link between NAD and exercise and fasting is that NAD is thought to be a bit of a sensor of the energy status of the cell. So if your body is subject to some sort of energy stress, for example, if you're exercising and it's using up energy, or if you're fasting and energy is depleting and it's not getting a renewed source of energy, the cell almost says, okay, we're going into a state of energy stress and we need to do something about this to basically try and survive this period of stress. So what it does is energy sensors such as AMPK basically activate pathways in the cell and enzymes in the cell that make NAD. So your NAD levels will go up, and this will basically switch on energy production via the mitochondria, and also it will switch on the sirtuins that will activate lots of downstream pathways that will help the cell basically survive the stress by switching on autophagy, for example, so things are recycled and reused, by activating pathways that are going to induce repair and basically make sure our cells can survive this period. So this is why NAD can be boosted naturally by doing exercise and fasting. But on the flip side, your NAD levels will also be very low if you are not exercising and you are eating constantly, because those pathways will simply not be getting naturally activated.
Yeah, I mean, these are probably one of the, or two of the most known reasons associated with disease and aging. So it makes a total sense to me that there is an actual molecular explanation in a very deep cellular level on why exercise and fasting or restricting calories is beneficial in reversing aging and preventing disease. What are some of the symptoms of low NAD, or is it something that you can see and feel that you have low NAD?
Yeah, I mean, I think the simplest way to describe it is like, you know, when you see a young child running around and they've got so much energy and like it doesn't matter if they've had no sleep, they will still have energy. That's because they have high NAD as opposed to...
I wish I could have that back, I must say. I really wish I would. I'm like horrible if I'm sleep deprived. The next day is ruined.
Exactly. Well, that's it, you know, because you are already functioning at a slightly lower level because you know, your cells are struggling a little bit because they don't have that NAD for the energy production repair. It's got to be spread around a bit further. But, you know, in terms of how people feel, it's definitely energy. It's kind of not having that energy resilience, that backup supply. And it's not just physical energy, it's also mental energy. We know that NAD is incredibly important in the brain. People with low NAD and conditions that are associated with low NAD tend to suffer from brain fog, and that can be restored and remove that brain fog after you know, boosting NAD levels. So I think those two are probably the most important. Also, disrupted sleep. So we know that NAD is incredibly important in the regulation of our circadian rhythm. So again, you tend to find that people with issues with the NAD have disrupted sleep patterns, shift workers, people like that.
Is there a way to measure NAD, like vitamins and minerals in the body? Can we go to a lab and be like, okay, this is how much I have NAD and it's not optimal, or it is optimal, or is this something that haven't yet been developed?
So you can test it. So there are ways to test it. The issue with testing NAD is that it's a really unstable molecule. So when you're testing NAD, so example, if you took a blood sample from someone, this basically needs to go on ice immediately, and then the cells need to be immediately extracted to preserve the NAD, and make sure that you're actually measuring what it is that you've took out of the person, because NAD flips between many different states very easily. So if you don't have these measures in place, it will degrade and you'll not be measuring a real effect. Because of this, it's been very difficult to develop consumer tests where people can just, do a blood test like they can with some things, and send it away in the post and then get a number back or a result. There are companies that are trying to do it, but I know from firsthand experience of measuring NAD, it's very difficult. It degrades, and it's a bit of an obstacle to get over to convert it into consumer testing. But hopefully that will become available so more people can test their own NAD levels. But at the minute, it's kind of restricted to academic labs.
Yeah. Okay. So we just kind of have to rely on how we feel.
Yeah.
Okay. How do the NAD get into our body and our cells, or is it something that you already mentioned that the body produces NAD? Is it a constant supply, internal cellular supply, or can we get it from food, for example?
Yeah, so our body is actually really good at making NAD, and this again makes perfect sense because it's so important. We wouldn't really want to rely on an external source of NAD in case we didn't get it. So in our bodies, in our cells, we have something called the salvage pathway, and basically when NAD is used by the body, so for example, it's used by the DNA repair enzymes or the sirtuins, it's actually broken down into its building blocks, which are called precursors. And the main building block that it's broken down to is one called nicotinamide. Now, our cells actually recycle this straight back into fresh NAD again. So this is a really clever design, because what it means is that as NAD use goes up, you'll obviously get an increased amount of the breakdown products, and then recycling will simply increase, and it'll sustain the supply. So it's like a supply and demand thing. So it's a really clever design, and the majority of our NAD is actually made in this way. But what's been found is that it is actually this process that declines with age that has a major impact on our cellular NAD levels. So there's an enzyme within this pathway called NAMPT, and this is a rate limiting enzyme. So basically the amount of NAD produced is directly dependent on the amount of this enzyme that's available. And it's been found that this enzyme decreases in our cells and our tissues as we get older, which means that our bodies can't as efficiently recycle NAD anymore. Now, unfortunately, this also coincides with an increased demand for NAD, because we know that in older cells, we've got more damage, we've got more inflammation, and more NAD is actually being used up. So what you see in older cells is this increased demand. The NAD is getting used, it's getting broken down into nicotinamide, but that recycling pathway and that enzyme's not there to pick it up and recycle it. So you get like this perfect storm where use has gone up and recycling's gone down. And then this is why you see such an exponential decline in NAD with age.
So how can we support this NAPT?
Well, one thing is to switch it back on, and natural ways of doing it are, again, exercising and fasting. So, when I said before that these both increase NAD production, they do this by switching back on NAMPT and increasing the expression of this key enzyme. So those are natural ways that can be used. A lot of people are taking supplements to boost the NAD levels. And what they do is they generally contain precursors. So people that are familiar with NAD may have heard of supplements that contain ingredients like nicotinamide riboside, or NR it's usually called, or nicotinamide mononucleotide, which is usually referred to as NMN. And these are basically the precursors. These are the building blocks that the cell actually uses to make NAD. And people, take these in capsule form, and the idea is that, okay, if NAD production's gone down, then can you give more of the raw material for your body to use and make into more NAD? And we know that some of it does get incorporated into NAD and boost NAD levels, but all this new research, what it's shown us is that actually this is completely, using precursors is completely ignoring the reason why NAD is declining, because you can give as much precursor as you want, but if you don't have that enzyme that's actually making and recycling the precursor, then basically, you're not really going to get a sustained boost in NAD. And a lot of the data shows it may actually make some of the issues of NAD decline worse.
What?
Yeah.
Okay, that's a shock. So wait, I've also heard about NMN. I have actually used NMN.
Mm-hmm.
So you are basically saying that these supplements that are now marketed as the most efficient way to boost NAD are actually making things worse in some cases.
So if you look at the science, they are completely ignoring the reasons NAD declines. So we absolutely know that the two main reasons NAD declines are, firstly, because the enzyme in the salvage pathway that recycles NAD declines with age. The second thing is a molecule or a protein, an enzyme even, called CD38. Now, CD38 is an inflammatory enzyme. We know that it becomes overexpressed as we get older because our cells generally in our bodies suffer from chronic low-grade inflammation. And CD38 is a huge NAD consumer. So for every one enzymatic cycle that it does, it actually uses 100 molecules of NAD. So this is way more than the sirtuins or the DNA repair enzymes use. They use, like about 6 or 7 molecules. It uses 100. So this means that as we get older, we get chronic inflammation. CD38 will literally eat up all our NAD levels. So those are the two key reasons why it declines. So simply by ignoring those and just putting more raw material in and hoping that the body's going to make it into NAD is not addressing those issues. So one of the arguments is, okay, but any NMN, if you look at a pathway of NAD production and recycling, NMN actually comes into the pathway below this enzyme that's the problematic enzyme that declines with age. So a lot of people say, well, okay, but it doesn't matter because, the NMN is bypassing the problem with this enzyme and it will get made into NAD. But actually, we know that even when it's been made into NAD, once that NAD is being used once by the sirtuins, the repair enzymes, CD38 even, it's broken back down into nicotinamide. And then that nicotinamide needs to go somewhere. It needs to be recycled. And that's where the block in the road is essentially, because if we're putting more NMN into the system, it's increasing NAD, it's getting used, it's getting broken down into nicotinamide, but then it needs to be recycled. And if you don't have a functioning salvage pathway, if you don't have that enzyme working, it can't be recycled. So what you see is it actually builds up within the cell. And cells generally don't like it when things build up. So what then happens is we see that cells start to overexpress another enzyme called NMMT. And this is a methylating enzyme. And what it does is it sticks a methyl group onto the nicotinamide to make methyl nicotinamide to excrete it from the cell, to get rid of it. And if you look at a lot of the papers that have been published using precursors, what you'll see is that if you increase the dose of the precursor, yes, you increase NAD, but it plateaus. And what continues to go up, up, up is the excretion of methyl nicotinamide as the cell's almost panicking, like, how do I get rid of this breakdown product? And that causes other issues because basically methyl groups are incredibly important for our epigenetics. And there's a lot of worry about methyl donor depletion when taking precursors. So, you'll often hear people say, oh, if you take an NMN, you better take trimethylglycine so you don't become methyl donor depleted. So it's a very clear example of how trying to use something to fix something without actually addressing the root cause can actually cause other issues. The other big one is inflammation, so there's a real worry now that actually if you're boosting NAD in older cells that have overexpressed CD38, is that NAD actually going to where you want it to go? Is it going to the sirtuins? Is it going to DNA repair? Or is it being used up by CD38? And we know CD38 has a higher affinity for NAD, which means it'll grab NAD before any of the other beneficial pathways like the sirtuins and the DNA repair enzymes. So again, we can't ignore why NAD is declining. And really, if you want to boost NAD, you should be looking at inhibiting CD38 and actually switching back on the salvage pathway and addressing the root causes.
I was just about to ask that because as far as I've now understood is that it doesn't work if we just take the supplements. We need to address the CD38. Can you tell more about the CD38 and how can we inhibit that one?
Yeah, so CD38 is, there's studies that have demonstrated that you can have almost a 50% increase in your NAD levels just by inhibiting CD38. So there's a compound called apigenin that can be used as an inhibitor of CD38. And I guess that, this is what we've tried to do at Nuchino. We've tried to look at when developing products to boost NAD of how we can actually address the root causes of NAD decline. So, in the product we've developed to boost NAD, it's actually looking at ingredients that are increasing expression of that key enzyme. It's actually looking at ingredients that are going to inhibit CD38 and prevent NAD being wasted by this inflammatory process. It's looking at ingredients that will inhibit the methylation problem. And actually, what we say is take that whole system approach and actually don't ignore the underlying biology, but actually address it and take measures to actually try and fix it.
How is your approach different? What do you do basically to inhibit the CD38?
Yeah, so for our product, basically for the CD38 inhibitor, we use actually parsley extract. And a lot of people go, why on earth have you got parsley in your product? And what has that got to do with NAD? But what we know is that parsley has a very high concentration of this apigenin molecule. And people go, well, why don't you just put apigenin in it? But we know that apigenin is actually quite poorly absorbed in its singular form, and it's much better absorbed when it's used as more of a whole molecule within food type substance. It almost protects it in the gut and allows it to get into the cells and actually where we want it to work. So that's what we actually use to inhibit levels of CD38 in the product. The other things that we do is we use rutin. So rutin contains a compound called quercetin. Quercetin is one of these things that it has poor bioavailability. And if you use it in a different format, you can actually increase that. So that's why we use the rutin in our product. And rutin is a direct activator of NAMPT. So that enzyme that declines with age. We also have a compound in there called alpha lipoic acid, and alpha lipoic acid stimulates AMPK. And we've actually done clinical studies on our product. So we've done a double-blinded, placebo-controlled crossover study on 28 people to actually prove that our product is working in a different way to precursors. It's actually switching back on that enzyme. And we saw a significant increase in expression of NAMPT and also, some of the downstream pathways such as the sirtuins.
Is this supplement or RNAD boosting supplements something that people at all age should be considering?
Yeah, so this is a question I often get asked. I always say that if I had to pick an age, because everyone just likes a number, I would say definitely by your 30s you should be looking at ways to maintain your NAD levels. Because what we know is that it's much better to maintain levels rather than let them drop and then try to recover them again. And in our clinical study, we actually used volunteers that were both male and female, all the way from age 20 to 80, which is really unusual for a clinical trial. Usually when it's anything to do with aging, it will be, 55 to 65-year-old men, definitely not women and definitely not younger people. So we wanted to demonstrate that this was something that could actually have a benefit across a wide range of ages. And we saw across all of those people that the product did actually increase NAD levels.
Have you done any studies in different symptoms or the symptoms of declined NAD levels like brain fog or mental energy or mood or something like that?
So for this particular study, we were very focused on more the biomarkers, so the mechanism of action. So what we didn't look at in this study was, the health outcomes. So, in the future, that is something we'd like to do. But what I can say is, from anecdotal evidence from our customers, the top things that people come back to us all the time are how it's massively helped with their energy levels, how it's removed brain fog. And I think the key segment of customers that we get this from are perimenopausal and menopausal women. But as
Why do you think that is?
So this is something we want to do more research into, but actually I think theoretically the reason probably is that if you think about it, the age at which women are going through menopause, so average age is 51 years old, their estrogen is suddenly taking a dive, and at the same time their NAD is taking a dive, and we know that both estrogen and NAD are incredibly important for normal mitochondrial function, for energy production. So these two factors coming together are going to really hamper both our physical and our mental energy. And it's kind of like the perfect storm of these two things occurring at the same time. So if we can at least fix one of those issues and try and get NAD back up, I think that is why we see such a beneficial effect in this certain population of people.
Wow, okay. Knowing all that you know now about NAD and about the studies or about the research that you've done and looked at and reviewed and all of your knowledge, what is the advice that you would have given to your younger self, or is there such?
I think, for me, that when people ask me what's my sort of one piece of advice, I would say that, despite everything that we're learning in terms of longevity and the science, everybody is an individual. And I think the best thing that you can do is understand your own body and your own biology and how your body and biology reacts to things, and basically get a very good understanding of your biology when you're in good health. So I've got Oura Ring, I've got glucose monitor, I do get my bloods taken. I know, what my baseline levels are for things, get your hormones tested, and just have a really good understanding of where your levels of things should be at when you are feeling good. Because then if something starts to change, you can spot it a mile off. And often what happens is, people go to the doctor because they feel rubbish, and then the doctor says, oh, well, you're within normal range, so it's fine. And it's like, but that's not normal range for me. And I'm telling you, I don't feel good. And so I think, just generally looking after your health, understanding your biology. I always say you've got to get the basics right. And make sure they're all in order before you start investing large amounts of money in all sorts of supplements and, different health hacks. Just get the baselines right first. Quite often it's harder to fix the damage than actually prevent it in the first place.
Yeah, you're absolutely right. Those were such good words of wisdom. And I'm just super grateful for you for sharing all this knowledge and information about NAD and aging. This definitely gave me a lot of thoughts, I'm sure, for the listeners as well. How can people find more of your work?
So my company is called Nuchino. That's Nuchido. They can find more information about the products and our clinical studies at nuchino.com. We're mostly work on Instagram, so look for Nuchino on Instagram. And also myself, I'm just Dr. Nichola Conlon. I do quite a bit on Instagram. All about aging, healthy aging, not just NAD, but all sorts of things.
Your Instagram is amazing. Yeah.
Thank you.
It's very good source of information for this topic. So I definitely encourage everyone and anyone who is listening right now to go and find Dr. Conlon on Instagram, because there is so much good knowledge and all for free. So
perfect. Well, thank you so much for having me.
Thank you. Hey, thanks for watching. If you like this video and want to learn more, keep watching. This is a good one.